Okay, let's start. First things first, for simple machine, first things first, what we'll be doing is first definition of machine, definition. After definition, we'll talk about MA. What is MA? Mechanical advantage. Talk about VA, VR, that is velocity ratio. After velocity ratio, we'll talk about types of machine, types, types of machine. Then after that, we talk about efficiency. Then we close for machine efficiency. So with this, we are done with machine. So machine is kind of something. Definition now. Definition machine. Definition right. Machine is a device, or simple machine is a device. Simple machine is a device that overcomes large load with small effort. Overcomes, the keyword here, overcomes large load with small effort. Now note something. This load is force. And what is unit for force? Newton. This effort is force. What is the unit of force? What is the unit of force? Newton. So just know that machine overcomes large load with simple effort. That's one thing. Then you know that load is force, effort is load is force, effort is also force. That's why when we are talking about mechanical advantage is just like mechanical advantage. Let me see. Advantage MA is equal to load over effort. Load over effort. If you want to do the what they call this stuff, if you want to do dimension for this stuff, force, which is Newton, it does not have a unit. That's the main thing I want to say. It does not have what a unit. So note, mechanical advantage does not have a unit. Mechanical advantage does not have a unit. When they say if a machine is ideal, when they say a machine is ideal, what does it mean? When they say a machine is ideal, what does it mean? Machine is ideal. When they say a machine is ideal, what does it mean? You have any idea? When they say machine is ideal, you have any idea? When they say machine is ideal, it means it is perfect. Perfect. Not perfect. Now, this is when efficiency is 100%. Machine is 100%. When a machine is 100% efficient, call it an ideal machine. You get? But this is not possible. It's not possible because of friction and the rest. You get? Because of friction, no machine is 100% perfect. Even you, you're not 100% perfect, have you? Yes. So that's just it. So we are done with mechanical advantage, right? Now the next thing we'll be doing is velocity ratio. Velocity ratio is the inverse of mechanical advantage. Velocity ratio is equals to effort over load. Still the same thing, no units. Still the same thing, no units. Okay, right. If the mechanical advantage of a machine is 4, mechanical advantage of a machine is 4, what is the ratio of the load to effort? If the mechanical advantage of a machine is 4, that's equal to 4. If the mechanical advantage of a machine is equal to 4, what is the ratio of the load to the effort? The ratio of the load to the effort. Sharp. It's nice. It's nice. The question is nice. It's simple. Abi? The question is nice. It's simple. See now. Mechanical advantage MA is equals to 4. Remember, your formula, mechanical advantage. Okay, yeah, is perimeter. From the question, perimeter is mechanical advantage is equals to 4. Load was not given. Effort was not given. Abi? Now, if your mechanical advantage, which is mechanical advantage is equals to load over effort, is equals to 4 already, what is load? What is effort? What is effort? Let's say effort A. What can you divide? When you divide it by this, will give you 4. That's just how you solve it. You get, you can say 16/4. You get 16/4 will give you 4. But they say ratio. Ratio. So they mean the smallest. The smallest. What will be the smallest? 4/1. 4/1 will give you what? 4. That's the mechanical advantage. You understand? Over 2. Abi? 8/2. But we need the smallest. The smallest will be 4/1. Even though when you reduce this stuff, it still be 4/1 self. Reduce this stuff, it will be 4/1. You get? Just common sense. Just look at it critically. If load over effort is equals to mechanical advantage, would not give you mechanical advantage before the two of them. Just use ratio. That's why they say ratio smallest. You get, so write the question and write the solution. You get? Thank you for that question. Okay. Which of the following is true about a machine? Which of the following is true about a machine? You have not reached efficiency, but just listen. Which of the following is true about a machine? A. Efficiency is 0. B. Efficiency is greater than 100. C. Efficiency is less than 100. D. Efficiency is 100 of a machine, not an ID machine. You just say of a machine. What is the answer? Right, oh. I should come again. Which of the following is true about a machine? Which of the following is true about a machine? A. Efficiency is 0. B. Efficiency is greater than 100. C. Efficiency is less than 100. D. Efficiency is 100. What is the answer? Okay. Flourish, what is the answer? What's the answer? What's the answer? I said, what's the answer first before I will not? What's the answer? Less than 100. That's the answer. Yeah, no. I told you, only in an ideal machine that efficiency is equals to 100. Did they say anything like ideal machine? They just say a machine. So it's less than 100. Less than 100. So that's it. Efficiency is less than 100. In a machine, or not ideal machine, in a machine, efficiency is less than 100. We have done definition, we have done mechanical advantage, we have done velocity ratio. We are going to types. In all the types of machine, we have lever types of machine. We have lever, we have what again? We have pulley system. We have pulley system. We have inclined plane. We have wheel and axle, very good. Wheels and axle. Yeah, axle. We have screw. That's fine, screw. You know this stuff, and there's this one said there's no calculation under this one. What you just need to do is just to know the first class, second class, and third class you get. You know this stuff, what differs in all of them is the velocity ratio. If you can get their velocity ratio, you can solve any question under the types of machine. You get me? Let me explain. First of all, let's take the lever. Let's lever that efficiency, effort is one side, load is one side, then the pivot is at the middle. You get? So right. First class machine, first class lever machine are machines where effort, vacuum, and load. These are usually put it here. These are it is. Effort, vacuum, and load. This is for first class. Then second class, there's how we know second class. There's how you usually know second class. F. You know F, now those stuff with long ear. Yes, they are the second class. The second class F. Now in F, load is at the middle. Fulcrum is at the end. Then effort is at this side. We'll find some examples under this stuff. Oh yeah, you understand? Now, if you already know that load is here for first class, effort is here for first class, fulcrum is here, then your mind should just tell you that what should be in the third class should be effort in the middle. You understand? Then fulcrum can be this side. Load can be this side. Or you can exchange. Look at this stuff, they can exchange. You can exchange, you get. Just like you turning this stuff like this, turning this stuff like this. You understand? Understand? Now, let's give an example. For first class, we have some example. We have scissors. Scissors. We have scissors. We have hammer. We have plier. That's for first class. We have scissors. We have hammer. We have plier. Second class, we have wheelbarrow. For the third class, they say arm, forearm, the forearm. Effort, load, okay, fulcrum, type of machine, pulley system, pulley system, pulley system, the next type of machine. Pulley system, something like this. Yeah, they usually do it. Load is attached here. 1, 2, 3. Thank you very much. I hope you understand. What's up? I hope you understand. This is how police system looks like. Looks like. I don't say this like this. Now, let's say there's a rope now that will be attached here. This is effort. Now, this load, this rope, this load. You just use small efforts to overcome large load. Small efforts. There are some calculations under this thing, but it's very simple. Small effort to overcome large load. Now, there's something you should know. I think you remember MA is equal to what? Load over effort. VR is equal to what? Effort over load. Now, in pulley system, your VR is just the number of track. Here. The number of circular something. Let's say circular something. Let me get a better stuff for it. Next one I did was before I put the rope. Next one I did was this one. So I send the board. This follow. I send the board 2. Next one is this 3. So how many is here? 1, 2, 3. Not this smaller circle. This one. Let's say this one are the knots. This one are the bolts that like. But this 1, 2, 3. You get me? 1, 2, 3. You get me? Thank you very much. Thank you very much. Now for this stuff, the velocity ratio for pulley system is how many? Here 3. You get it? The number of 1, 2, 3 is the velocity ratio. Number of that stuff is what? Velocity ratio. So they don't even tell you about velocity ratio at all. When they are giving the question, they don't say velocity ratio is this. They say you can calculate the efficiency. They don't even tell you velocity ratio is the velocity. They just go straight to the point and tell you if this is this, find effort. They may give you only this part. They may even give you this part. And that's the find effort. You knowing that 1, 2, 3 is what? 3 velocity ratio. You just use it and put it there. Okay, that's just that's just it. I want to touch efficiency. This thing will make sense. I'm solving questions and because most of the questions here are efficiency. You get efficiency. Don't just touch efficiency. I'll just touch it small. Just small. I want to understand efficiency. Just small. Don't go back. Efficiency is the formula for efficiency. Efficiency is equals to MA over VR times 100. Let's write this down. MA efficiency is equal to mechanical advantage over velocity ratio times 100, right? Mechanical advantage is equal to velocity. Efficiency is equal to mechanical advantage over velocity ratio times 100. Efficiency is equal to mechanical advantage over velocity ratio times 100. Velocity ratio times. You already know that mechanical advantage is what? Mechanical advantage is equal to LE. You know that velocity ratio is the number of block or let's say block. Let's call it track. Number of track in pulley system. Yes. Thank you. So we have a question here. Calculate the efficiency. Okay, they say the efficiency of a pulley system that is shown here. Give it the drawing that is shown here. The efficiency that is shown above. The efficiency of a pulley system that is shown above is equal to 80%. Find the effort. Find the effort E required to lift a load. Of 1200 Newton. That's 1200 Newton. Calculate. First of all, let me clean this board. See, we're in types, so I'll clean this board. So read the question for me again. Read the question again for me. Read the question. Okay. So this is the pulley system. Let me just try and join it to these ones. Let's say it was joined to these ones, something like this. So this is the pulley system. So from here, they say load is how many? 1218. Here, efficiency is equals to 80%. Load is equals to, we are using what they gave us first. Effort, that's what we are looking for. Velocity ratio was given, you know like that. Velocity ratio is what? Velocity ratio is what? Leave this line. I drew this one before now. Velocity ratio is what? 4. God bless you. This is velocity ratio. There's no need for velocity ratio. So they say we should find what? Effort. Remember, formula for efficiency is equal to load over effort. Permit me, load over effort, which is mechanical advantage over velocity ratio times 100%. Voila. With this, you can solve the question. We're looking for what? Effort. So here, 80%. Remember, if you put 80% like this, you multiply it by 100. Look at it. If you do it like this, the load is 120 over effort. That's what we're looking for. Over 4. Over 1. 4 over 1. 4 over 1 is 4. So just open like this. Multiply by 100. If you do this 80% like this, you multiply by 100. But if you remove it like this, remember 80% is equal to 80 over 100. You remove this 100 this side. I like this. I like something like this. You get. So there's something like to solve this fraction. You can do 120 over E divided by 4 over 1 AB. This stuff, then you now rotate it and do times 1 over 4, reciprocal 1 over 4. You get. Or simply you can do far and far, near and near. Look at it, look at it. You can do far and far, near and near. This times this is 120. 1200. Then this times this is 4E. AB. Far and far, near and near. This times this 120. 1200. Then this times this is 4E. That's far and far, near and near. You understand? Far and far, near and near is also the same thing like this. So we can clean this stuff here. And put 120 over 4e. You know how I got this place? This stuff, we replace, we get this point. You understand? Shalom, you understand? So this is it. So cross multiply and get your answer. We're looking for e. So anything you're doing, then just continue. Next one, just solve it on your own. This is further equals to 80 times 4e is equals to 120, 1200 times 100. And even reduce it from yourself. Get so we have 8 times 4 for 10. Continue. What is your answer? What is your answer? We have, what is your answer, Flourish? Say E is equals to first person say 375. You have not finished. No, your answer is on the board already. You're wrong, go. Check up again. So let me read the option. Now let me tell you why you're wrong from the option. Are you sure that's your answer? What is that in code? 375. Finish. Okay, let me tell you why you're wrong. Number one, A 275 Newton. Why that? B 325 Newton. C 375 Newton. D 573 Newton. So are you correct? No. Answer now. 375 is it correct? It's not correct. Is it 375 biscuits? I mean 375 biscuits. So anything you're solving in physics, always put your unit. If there's unit, always put your unit. If there's no unit, check where if there's no unit. Because there are sometimes they'll be unit, but you don't know. So check where if there's unit. So that's it for that. Then check out this question. Velocity ratio of a machine is 4. The velocity ratio of a machine is 4. If its effort is 800 and load is 1600. If its effort is 800 and its load is 1600 and its load is 1000, calculate the efficiency of the machine. So the question is, velocity ratio is what? Load is what? 1600. Efficiency is what? Effort is what? Wait. I need to stop in that. Effort is 800. Let's say efficiency. Let's do efficiency like this. Efficiency is what we're looking for. Please, in case of next time, do efficiency like this. They will not put EE and confuse ourselves. Efficiency like this. Thank you. What is the answer? Maybe I write this. Just give me the answer. Abina. Eh? No. This effort is 800. Sorry. Solve. If you're watching this video, you can pause and solve. If you're watching, you can pause and solve for those people that are online. All right. So, answer. Speed and accuracy. That's what I need. That's what I just love. I just love speed and accuracy. 50%. We have option A, 2%. Shalom, I done. Option B, 40%. Option C, 50%. D, 60%. What's your answer? What is your answer? 50. 50 is correct. It's not better. It's 0. 60 is still yet. So check. Check. After this, we'll go to the next machine. Hope you wrote out those types of machine. You send them. Hope you've been for 3 hours. There's some X. 50. Okay, thank you. Let's solve for those plan right. We have efficiency to be equal to what? Mechanical advantage over velocity ratio times 100%. Now listen. Mechanical advantage is what? Load over effort. We have load to be 160, 1600 over effort 800 over velocity ratio 4 over 1. Let's just put it like this. Then times 100. We're looking for efficiency. Now this can go Abi. So we have far and far, near and near. We have 16 over 8 times 4 times 100. Abi 8 times 4 is 100. So this is 5.0 times 100. Abi. Thank you very much. That's on that. You are correct. So next thing now. Anyhow, my own just get this speed and accuracy. Incline plane, Abi. Incline plane. Now what's an incline plane? Incline plane. Now see how an incline plane looks like. Look at the ball. Here's an incline plane looks like. It's on the floor. So this is an incline plane looks like. You have seen it before, right? Or I should say you have not seen it before. Have you seen they're loading something into a truck before? Now they put a wedge. Very good. A wedge like something 1 over VR is equal to 1 over sin theta. This is one usually bring on it. Yes, we already know that velocity ratio is VR. Velocity ratio is 1 over sin theta. That's just it. Therefore, velocity ratio of here is what 1, 2, 3. Just count the number of stops. That's the velocity ratio. Understand? Thank you. Now the question you see, that's how you know. Any question you see, theta. Right. In an incline plane of angle theta, acting as a simple machine, what is the velocity ratio? What is the velocity ratio? A simple machine. What is the velocity ratio? What is the velocity ratio of that machine? It's simple. Looking about incline plane. Okay, I should give you option. I think option will help you. The velocity ratio, they say A, sin theta. They say B, 1 over sin theta. C, cos theta. D, 1 over cos theta. E, cos theta, sin theta. What's the answer? 1 over sin theta. That's just the answer. Let me find the question. What a thing. Sharp. Right. A 20 kg mass. A 20 kg mass is pulled up in an incline plane of angle 30 degrees. A 20 kg mass is pulled up an inclined plane of angle 30 degrees. if the efficiency of the plane is 75 degrees, 75%, sorry, 75%, and the force required to pull the load is question mark. This question, they give us inclined plane of how many? This is equal to what? That's what they usually give. Then efficiency is equal to what? 75 degree. They said what are we looking for? Yes, before that means they're giving us the load already. The load is equal to what? 20. There's a load of a mass of what? 20 kg. Listen, force is equal to mass times velocity, mass times acceleration. But we're using velocity because it's kind of acting against velocity. We're using gravity, mass times gravity. So note, we can change this stuff. We need to change this stuff to force, not mass. So when you change this force, when you change this mass to force, it will be 20 times 10. Acceleration to gravity is always 10 now. It's equals to force. Force will be equal to what? 200 newton. So this stuff, don't use 20 kg because what is your option? Your effort in your option is not in kg, it's in newton. It's in newton. So hold on, don't leave it. So the stuff we are discussing here is 200 newton. 200 newton. 200 newton. You can solve this stuff now, Abby. You can solve it, Abby. And let's solve. If efficiency is equals to mechanical advantage over velocity ratio, but velocity ratio is equals to 1 over sin theta. Listen, velocity ratio is equals to 1 over sin theta. Sin 30, Abby, that's theta here. So we have sin. So velocity ratio is equals to 2. Velocity ratio is equals to 2. We have mechanical advantage as L over E over 2. L was given as 200. Abi, L was given as 200 over 1. You understand now? What will I do? Far and far, near and near. Far and far, near and near. Far and far, near and near will give me 200 over 2E. Efficiency was given. Let's clean the bottom. Make it better. See, I'm coming. I'll need space. We have efficiency to be 75%. If you're using this percent, remember you multiply by 100. But prefer to use this one. 100 is equals to 200 over 2E. 2E. So we must cross multiply. We have these times let's just multiply. We have 200 times 100. 200 times 100 is equals to 75 times 2E. From there you can continue. Understand me? We are saying that 200 times 100. So look at it. 150E. Then we have 200. So this is 20,000 divided by 150. 20,000 divided by 150 give you 3.133.3. Abi, is what you got? Is what you got? 0.3. Abi, so we have effort to be equal to 133.33333 watts. Thank you very much. That's just it. So if you want to convert this into kg, now what do you do? What do you do? If your option is giving you kg, remember you divide by 10, go back to kg. That's just it. Divide by, but they don't give you options in kg, they give you as in newton. So that's on inclined plane. Note, what you just need to do is to understand that inclined plane works with sine. 1 over sine. After inclined plane is what? Wheel and axle. Abi? Check. Wheel and axle. Abi? Is it wheel and axle? Wheel and axle. Abi? That's just it. Now say yes or no. You know that in simple machine. This is the most important thing in simple machine is that the velocity ratio differs. And if you know that the velocity ratio differs, then you know that all I'm coming. I need to see this part where. So this part is the most interesting part. Let me see it where. In types of machine, what differs is the velocity ratio. If you can identify the velocity ratio of each machine, we have pulley system, we have inclined plane, we have wheel and axle, then we have screw. For pulley system, the velocity ratio is just to count the number of blocks. For inclined plane, the velocity ratio is 1 over sin theta. Then for wheel and axle, that's what we are going to now. Wheel and axle, the velocity ratio is big R over small r. R means the radius of the wheel, and the small r is the radius of the axle. Now, for screw, we have 2 pi r over p. All those stuff. If you know that this stuff differs, the only thing that differs is the velocity ratio. Efficiency is constant. The mechanical advantage is always constant. The formula is always constant. That's always constant. That's just it. You get it? So we're entering what? Wheel and axle now. Wheel and axle. Now for wheel and axle, I told you listen, wheel and axle, let me see if I can get the drawing. Alright. For wheel and axle, you know that there is a big one. Have you drawn well? Have you drawn water from well before? This is the axle, then the wheel is rotating. You just be doing like this, doing like this. Note, it's a simple machine, so even a small child can even use it. What is machine? A machine is a device that overcomes large load, which is the water they are trying to, the bucket of water they are trying to draw, with simple efforts, just like this. It's moving. Are you getting what I'm saying? That's just it. Now, the velocity ratio, that's what we are going to now. The velocity ratio, when they are calculating the velocity ratio of this machine, is equals to r over small r. R here is the radius. Now, this is the radius of the wheel, and this is the radius of the axle. In a typical question, they will not say this is the radius of the wheel. They will just give you the radius of a wheel and axle. Listen, don't write. Listen first. in a typical question, they will not say this is the radius of the wheel, this is the radius. They say in a radius, you just say the radius of the wheel and axle of a machine is this and this respectively. They said what wheel and axle, abi, is this and this respectively. It means that this one comes before this one. That's just it. I have a question here. Oh. Check out this question. A wheel and axle has a radius. A wheel and axle has a radius of a wheel and axle has a radius 80 cm and 10 cm respectively. If the efficiency 80 cm, if 80 cm and 10 cm respectively, if the efficiency of the machine is 0.85, is 0.85, if the efficiency of the machine is 0.85, and a force was applied, a force was applied to raise a load, a force was applied to raise a load, the force that was applied is 1,200 Newton, 1,200 Newton. What is the load? What is the mass of the load? What is the force of the load? Or what is the load? Anyhow, you understand me? You understand the question? They said the wheel is equal to what? 80 cm. The axle, the radius of the axle is small r is equal to 10 cm. The velocity ratio, find the velocity ratio using these two. The velocity ratio, you can find it. Mechanical advantage. Let's just say the load is how many? The effort is how many? Is it what we're looking for? Effort is 1,200. The load was not given. Listen, efficiency was given as what? 0.85. What does this mean? It means that they have already done 85 divided by 100. That does it. So they have done it divided by 100. Just work with this as 0.85. That does it. Can you solve it? Yes, you can solve it. Remember, velocity ratio is big R over small r. There's a question they just give you. I'll give you again. I'll give you a question. Now. There's a question just give. What's the velocity ratio of wheel and axle? Just write big R over small r. R over 1 over 2. Just solve. Velocity ratio first. Velocity ratio is big R over small r. So we have 80 over 10. So 8. We work with 8 cm as well. Velocity ratio. No, 8. Remember, cm is here, cm is here. So cm cancels cm. So just velocity ratio is 8. Understand? Shall we understand? Should I click? You're almost done. Don't worry. You got 8 and you're almost done. We have 8. Velocity ratio to be 8. And if you have velocity ratio to be 8, efficiency is equals to mechanical advantage over velocity ratio times 100. Efficiency was given as 0.85. Velocity ratio is good over effort. Effort was given as 120, 1,200. Velocity ratio is 8 times. Don't do times 100 again. I get in this scope. If you do times 100 now, this guy will go back to the normal form. So you can, if you don't understand that, this guy just look like this and put 85 over 100. If you understand that it's 0.85, it's supposed to just be like this. Don't put times 100 again. Thank you very much. So what will I do now? Far and far, near and near. You understand? Talk. You understand? Thank you very much. 8. It's not 80. So we have something like 0.85 is equal to far and far L over this stuff. I get me. Let's do 8 times 1, 2, 0, 0. Well, if I do try 9600, check confirm 9600. So with this we are done. That's there. You can just do like this. You cross multiply. Load is equal to 9600 times this. Are you sure? Wait first. Okay, I've seen it. Times 0.85. Okay, yeah. We have 8160. Abi. So this is the answer. Sure. Is this the answer? This is not the answer. God bless you. Yeah. If it's load, I've made mistakes here. Like I said, if it's load or if it's effort or load, note it must have Newton. So that is it. So we have on that one now. Listen to this question. Listen to this. Yeah, listen to it. In an ideal wheel and axle system. Yes, right. It's a question. Wheel and axle system. In an ideal wheel and axle system. You want to guess? Okay, I'm not going to. In an ideal wheel and axle system, R stands for the radius of the wheel. Big R, capital R stands for the radius of the wheel, and small r stands for the radius of the axle. Sharp. This is nice. What is the mechanical advantage? I see a question is. They say what is what mechanical advantage? Not say what is the DC, no. Velocity ratio. Okay. Sharp. Listen. Before you go on, note. If a machine is ideal, listen. If a machine is ideal, the mechanical advantage is equal to the velocity ratio. You get advantage is equal to the velocity ratio. If a machine is ideal, so ideal is kind of a perfect machine. Something we just reason is not that possible. But if a machine is ideal, the mechanical advantage is equal to the velocity ratio. So what's the answer for that stuff? Over small r. Let's check the option. We have option A, big R over small r. We have option B, small r over big R all squared. Then option C, we have small r over big R. Then option D, big R. Now the key point. Listen. What you should underline if you are reading this question, what you underline is ideal. That's what made the question very unique. Ideal. Are you getting it? In an ideal wheel and axle. So if it's normal wheel and axle, if they say in a wheel and axle, they say what will be the answer? In a wheel and axle, so what is the mechanical advantage? They don't put ideal. What will be the answer? Small r over big R. That's what I say. No. No squared. So we are done with mechanical advantage for. So the next stuff now is what? Screw. Now the screw. In a screw, the velocity ratio is equal to 2 pi r over p. Now pi r, the r here is radius of the tummy bar. And now it's p is equal to the pitch. So in the question, you look at for these two things. This one is in cm. So you look at for these two things. In the question, look where you see it. I'll give you an equation there. Then look at see. Calculate the velocity ratio of a screw jack. Question. Calculate the velocity ratio of a screw jack of pitch 0.3 cm. 0.3 cm. If the length of the tummy bar, so this is not reduced. It's reduced now. If the length of the tummy bar is 21 cm, If the length of the tummy bar is 21 cm, this is length. R is equal to length of tummy bar. Length of tummy. If the length of the tummy, see, which is cm so now. According to this question, this video. So you get, so you can solve it now. Remember, in this question, don't take pi as equal to 22/7 or 3 points. Don't take it. Just solve it with pi. You get, solve it with limit pi. Take the pi. So the answer should be something like this. Let's say 8 pi. Pi should be in the answer. So they say solve it in respect to pi. That's pi should be in the question. So solve. The pitch, the length of the tummy bar is what? 21 cm. The pitch is equal to 0.3, 0.3 cm. So it's simple now. Velocity ratio is equal to 2 pi times 21 over 0.3. So we have 4 2 pi over 0.3. Then you can go on from here. I think with this we are done now. If you have any question, you can ask. So the answer is what? 145. That's just the answer. So thank you very much for coming. So with this, we have come to the end of the topic simple machine physics. I'm coming. So we are done with the class. So make sure you like, you comment, you share. Thank you.